vector addition and velocity addition. It's our next topic, chapter, what is it, chapter 3? Vector addition, I'm not going to spend a lot of time on. There are videos on it. We're going to do it in the lab, but you have to just review your trig functions if it's been a while for you since you've had trig. But we take a vector, something like this. Let's say that's a velocity vector, and it's oriented at some angle theta. I'll call that VI. And oftentimes what we want to do is combine vectors, right? Add them together, something like that. So maybe there's another velocity vector. Well, let me call it V1 and V2. How about? Oops. There we go. Let's say for some reason we wanted to combine these two. We wanted to add these two vectors together. So a couple of ways to do it. One is graphically. You get out your ruler and your protractor. You draw the first vector. You measure off theta. You measure the length of that first vector. So basically it should look identical to what I have up there. I'll move it a little lower. How's that? So there's my V1. Should look identical to V1 above it. Then you move out to the tip of that vector. That's your new, what should I use, blue? That's our new coordinate system now. And you measure off V2. So here would be our theta 2, and here's V2. And then what you do is you start at your starting point, and you go to your ending point, and you draw a vector in there. And that's the, I'll call that R. That's the resultant, where R is equal to the vector V1 plus the vector V2. Okay, graphically, right? You just get out your ruler, your protractor. If you're careful, if you draw it big enough and you're careful, you can actually get pretty accurate results that way. Not perfect, right? But not bad. Especially if you're doing a quick sketch on an exam just to see where your answer is going to end up, so that when you do it using your trig functions, you can just check to make sure you didn't punch the wrong button on your calculator and you're not way off, right? Okay, so how do we do it if we want an exact answer? We break those up into components, right? V1 is going to be V1 sub x in the x direction plus V1 sub y in the y direction. And how do we find those? Well, we look at our drawing here. We're looking for this part. This is going to be V1 sub x, and this is going to be our y. And then once we have x's and y's, we can add all the x's together, we can add all the y's together, right? They have to be pointing in the same direction. Okay, so that's going to be V1 times the cosine of theta 1. That's going to be V1 times the sine of theta 1. And V2 so far so good. V2, you have to define a positive direction. So I'm calling to the right as positive and up as positive. I used positive values for V1 and V2, x and y. Now for V1x and V1y. For V2, I need a negative value for my x direction, right? So I'm going to put that in here. This is going to be a negative V2 cosine of theta 2 and a positive V2 sine of theta 2. And now I can add those up, and I get my resultant is just add up the x and add up the y. All right. So lots of links on the website if you need some review with this. We'll do some more in lab. But where we're going to go pretty quickly with this, right now basically, is a simple application for vector addition, and that is to find a velocity given that something's moving. Let's say you can throw a ball at a very calibrated speed. You know it always. You always throw. You got a really good arm. You've got it calibrated. You always throw it at 20 meters per second. Okay. Now you stand in the back of a. So that would be the speed of the ball as measured by you, right? You're throwing it when it leaves your hand. With respect to you, it's going 20 meters per second. If you're standing on the ground and somebody else is standing next to you, they're also going to measure 20 meters per second. But if you're standing in the back of a pickup truck, and you throw the ball, and the truck was also moving, and your buddy is standing on the ground over here, what do they measure for the speed of the ball? Let's say the truck's moving 20 meters per second with respect to the ground, right? The truck usually measures its speed with respect to the ground. The truck's moving 20 meters per second with respect to the ground. And the ball is moving, we already said, 20 meters per second with respect to the truck now, right? Because you're standing on the truck. So this person measures it as 40 meters per second, right? Because if you didn't even throw it, if you just held the ball, the person standing on the ground would measure the speed of the ball as 20 meters per second, right? Because you're standing in the truck, and the truck's moving at 20 meters per second with respect to the person on the ground. Then you get up and you throw it at 20 meters per second with respect to you, and you're moving at 20 meters per second with respect to the ground, so now the ball is going 40 meters per second with respect to the ground. It's like a plane with a tailwind, right? When you fly, which way is it? When you fly to Asia, it takes a long time, right? When you fly back, you're with the jet stream. You come back much faster, right?